In these slides, we're going to talk about Q equals mc delta T. And so if you think back 2 lectures ago, Q stands for heat. And so this expression describes heat. So before we apply this equation, let's lay some of the groundwork for understanding how to use this and where these variables come from. And so the first idea is heat capacity. And so heat capacity of an object is the amount of heat needed to increase the temperature of an object exactly 1 degree Celsius. And so that lays out the groundwork for this other idea called specific heat. So specific heat is denoted as C, and specific heat is the amount of heat it takes to raise the temperature of 1 gram of substance 1 degree Celsius. And so you can look at it this way, the link between heat capacity and specific heat. And that link is specific heat is essentially heat capacity per gram. And so every substance has a different heat capacity. And so here's a chart. On this chart, the highest heat capacity is water, and the lowest heat capacity is mercury. And so if you look on the right column here, where it says calories per gram times Celsius, and you look at water, 1 calorie per gram times Celsius is basically the definition of a calorie, right? So it takes 1 calorie to change 1 gram of water 1 degree Celsius. And so if you look at this, you can think of it, since water has the highest specific heat here and mercury has the lowest specific heat, it takes a lot more energy to change a gram of water 1 degree Celsius because it has higher specific heat than it does to change 1 gram of mercury 1 degree Celsius. Let's take a closer look at this equation, Q equals mc delta T. And so Q, as we said, is heat, and that's either in joules or calories. M is grams, is mass in grams. C, as you saw on the previous slide, is specific heat, and the units are either joules over grams times Celsius or calories over grams times Celsius. It depends on which unit your energy is in. Delta T, so this triangle means delta, and it's in the Greek alphabet. It means change in science. So delta T means change of temperature, and that's in degrees Celsius. So you have you'll have 2 temperatures. You have an initial and a final. So this TF is the final, and it's minus TI, which is the initial. Let's go through some steps. And so if you're ever at a loss, here are the steps you will follow. Step 1 is algebraically reorganize equation for the variable being asked in the question. And so you'll be asked one variable and you have to rearrange the equation and then check the units of a given number to verify that they are correct. If not, you're going to have to convert the units. So if I give you Fahrenheit, you have to switch it to Celsius, for example. And then once everything's in the right unit, you're going to plug everything in to your equation. Then you're going to cancel the units to verify that you correctly set up the equation. So if your units don't cancel, you did something wrong. So you have to go back and fix it. And then number 5, you're going to compute the numerical answer. And then don't forget to retain the units that didn't cancel. And this also verifies, so for example, if you're calculating for heat, you better have calories or joules or you did something wrong. So then you have to go back. It's a way of checking your work. Okay, we'll go through 2 examples. So the first example is, what is the specific heat of a frying pan if it weighs 243 grams and its temperature changes from 25 degrees to 35 degrees when 500 joules of heat is absorbed? And so you have to look here. First, identify what is being asked of you. So this example asks for specific heat. And so then you go back to your equation. You identify where specific heat is. It's in green. That's why specific heat turned to green. And then you have to solve for C. And so you have to divide each side by M delta T, and you end up with this equation when you do so. And then you can plug all the numbers in at this point. So Q is heat. So you look for where you're given heat. And so 500 joules of heat. And you're going to divide it by mass times delta T. So you're going to find where mass is. That's 243 grams. And then you have your delta T, and you're given, so you have your final temperature, which is 35, and your initial temperature, which is 25. So you're going to take the difference. And then you do your order of operations. So you have to first take 35 minus 25, which is 10. And then you have to say 10 times 243, whatever that product is. And then that's going to be under 500. But before you do that, I forgot, you have to make sure that you end up with the right units. So nothing cancels here. So you're going to end up with joules over grams times Celsius, which is a unit of specific heat. So that's correct. So then you can plug everything in like I just previously said, and you get 0.20 joules per gram times Celsius. Okay, example 2. How much heat energy is required to raise the temperature of 55 grams of water from 25 degrees Celsius to 28.6 degrees Celsius? And it gives you the specific heat. So identify what is being asked of you in the problem. And so it says how much energy. So how much heat? So you're going to be looking for heat. And heat is purple. And so this equation, Q equals mc delta T, is already solved for Q, which is heat. And so you just take that equation, and then you just plug in all the numbers. So mass is 55 grams. And then C is 4.18 joules per gram times Celsius. And then delta T is 28.6 minus 25 degrees Celsius. Cancel your units. Make sure your units cancel. So you have grams on the top and grams on the bottom. Those are going to cancel. And then your Celsius is going to cancel because you have Celsius on top because you have the difference of temperatures. And then you have your specific heat that has Celsius on the bottom. Those are going to cancel. And so you're going to end up with joules. And heat is in joules. That's an acceptable unit. So you did something right. So you first have to take the difference of the temperatures. Then you're going to multiply it by 4.18, and then multiply it by 55 to get the joules. And you should have ended up with 828 joules.